Given these 2 points in the plane, the equation of the line containing those 2 points is given by this equation. And we want to prove that that's the equation. That determinant equals 0. That's the equation of the line. Well, recall that the area of the triangle containing points x1, y1, x2, y2, and x3, y3 is given by this determinant. x1, y1, the 3 points. There's 3 points. And then all 1s. And want to move this. Want to move this over a little bit, but it won't let me. Is given by 1/2 of that determinant, the absolute value of that. Okay. Now, question. What does it mean if this determinant equals 0? What does it mean when this determinant equals 0? So of course half of that determinant will be 0 and the absolute value will be 0. That is, the area is 0. Answer. The area can, let me actually put 1/2. The area containing those 3 points is 0. The area containing the 3 points, I don't want to write down the 3 points again. Those 3 points has, or I really should say, the triangle. The area of the triangle, the area of the triangle containing those 3 points has 0 area. Now, what exactly does it mean for the area of a triangle to be 0? Well, let's look at this. This is point A, this is point B. I'm going to try my best to let A and B be the same distance apart. And we're going to play games with point C and angle B. If angle B is, 165 degrees, we get this area. If angle B and AC will always be the same length, if angle B is a little bit larger, I think I said 165. What if I have 175? This area is pretty much, well, it's less than the area of that triangle. Now, what if I let angle B get to be really close to 180? Maybe now it's 178. Well, this area is the smallest of all of them. Now, if I put C right there, so the second side of the triangle will be that, and the third side, well, it's going to be right on top of it. That has area 0. So, what does it mean for this area to be 0? It means that these 3 points are collinear. Okay. Now, suppose we just have 2 points, x1, y1, and x2, y2. How do I get this to be, so I pick a third point, call it xy, and I tried my best, I hope I succeeded, tried my best to make the 3 points collinear. Okay, the 3 points are collinear. Now, we want to describe the relationship between x and y. And that relationship is, the equation of that line is the set of all points xy given the point x1, y1, given the point x2, y2, putting the ones down such that this equals 0. This determinant will give you the equation of all of these points. And again, what is special about these points? They're collinear with point 1 and point 2. Now, what is this determinant? It's x, y, 1, x1, y1, 1, x2, y2, 1, and then we repeat the first 2 columns. That's the first column repeated. This is the second column repeated. And the determinant will be that product, which is x times y1 plus y times x2 plus x1, y2. x1, y2. Minus, and we go in the other way. And I factored out the minus. So that product is just x2, y1 plus, because I factored out the minus, y2x plus x1y. And this is supposed to equal 0. Okay, so let us write it in a better form. Let's see how many x's we have. Well, I have y1 x's, and I'm taking away y2 x's. So I have y1 minus y2 x's. How many y's do I have? Well, I have x2 y's, and I am taking away x1 y's. Take away x1 y. And what is the constant? Plus x1, x2 minus x2, y1 equals 0. That is, y1 minus y2x is equal to x2 plus x2 minus x1y. I'll bring these two to the other side. So I get x2, y1 minus x1, y2. I will bring this over. So I have this left. x2 minus x1, y is equal to When I bring this over, it becomes negative. So I'll distribute the negative. I get y2 minus y1 times x plus this constant, x2, y1 minus x1, y2. Just verifying that we're doing this right. Now, the 2 points had to be different. So let's divide by x2 minus x1, x2 minus x1, x2 minus x1. So we have y is equal to, because by design that canceled, y2 minus y1 over x2 minus x1, that's the slope, times x plus the y-intercept, minus x1 y2 over x2 minus x1. Okay, so we do have it in the standard form. Let's actually work out one example. So just for the record, I argued why this works, and that's the proof. Now, let's just look at this determinant a little bit more carefully. The determinant gave us that. Okay? Now, we need to verify that that really is the y-intercept. Well, we have the point x1, y1. So that's y1. And the question is, does it equal to this constant times x1 plus this mess, x2, y1 minus x1, y2, all over the common denominator, which is really good. Okay, so when I add these, I know what the common denominator is. And the numerator is going to be x, part of the numerator is going to be x1 times each of these, which is x1, y2 minus x1, y1, plus this numerator, plus x2, y1 minus x1, y2. And x1, y2 minus x1, y2 canceled out. And we are left with this and that. And I can factor out a y1. I have positive x2 y1s, and I am taking away x1 y1s. And when I divide this by x2 minus x1, I do get back y1. I do have the y-intercept. Fair enough. We have to be careful. We have to do a separate case when x1 and x2 are equal to one another. That means we're going to have a vertical line. Because if you have 2 points, that's x1. If you have this point, x1, y1, and you have another point, x1, y2, different y value, well then you're going to have a vertical line and there is no slope. Do a separate case for that. It will work out. So we did show that given 2 points, x1, y1, x2, y2 in the plane, that the equation of the line containing those 2 points is this equation. That finishes this video. If you like videos like this, please subscribe to my channel. Tell your friends about it. Most of all, watch and learn.